Okay, everyone, welcome to the class today. We are going to be going through a tutorial for a 3D modeled spinning top. So this is the basic version. I'll do subsequent tutorials after this one on how we can do more complex processes. So I'm going to show you the basics right now and record that as a resource that you can then go and use. Our learning intentions for today will be to just start to understand and apply skills in 3D modeling with the objective of manufacturing our spinning tops using additive manufacturing technology, which is 3D printing. We're also going to gain a basic understanding of the modeling environment, so how to rotate, how to pan, how to look around our designs and select the appropriate things to make what we need to make. We're also going to go through basic, like I just said, basic navigation techniques. We're going to create our first basic spinning top with the full functionality that we need. And hopefully by the end of the tutorial, you'll have everything you need to do it. We're also going to go to saving our spinning top as an STL file as well. I'll take you through rendering and engineering drawing at a later date. So the tools we'll be using will be the sketch tool, the revolve tool, and the pattern repeat. We'll be using the pattern repeat to make holes for our weights, okay? We'll be building a little bit of tolerance into those holes. So things in additive manufacturing tend to print a bit smaller than our original intention. So if you make a hole of 5 millimeters diameter, it tends to print out at about 4.6 millimeters diameter. So you lose a bit of that precision there. It can be reliably inaccurate, so you can actually change your model in easy ways to account for that kind of thing. The processes we're going to go through, we're going to save an STL file. We're going to set the material for our spinning top to plastic. And we're also going to look at the center of mass of our spinning top. So I'll show you how to get that data in your modeling environment as well. So our success criteria for this particular task, your spinning top will spin and maintain inertia for at least 10 seconds. So we're looking for stable spinning. The design is easily printable. There's not too much crazy stuff added to it that's going to make it hard for the 3D printers to print stably without breaking or anything like that. You need to make something that's shooting straight, so to speak. So make a standardized, sensible design. As you start to iterate and do more research, you can do more experimental features. But keep in mind, this is a functional engineering task, and you're not getting marked on aesthetic qualities of your spinning top. The final success criteria is that you need to make your spinning top to the size requirement of 65 millimeters. Okay, all of the numbers that we input in Fusion 360 are in millimeters. Okay. So if you type in 65, it will be 65 millimeters or 6.5 centimeters. A lot of people tend to make, a lot of people can make mistakes with the scaling, especially in the first time they're doing their 3D modeling. Okay, and we'll swap over to Fusion now, and this will be, when you open up a new file, this will be what you'll see. So without further ado, I'll jump straight into it. The first thing that people get stuck on is they can't see any references. So you click and you click and you click and you can't actually select anything. What you need to do is go up to this area here and click the visibility button next to Origin. And that works the same way as other programs that have layers and things like that. You can make anything visible or invisible, and it can get really handy when you're working on complex models of multiple parts and multiple 3D bodies and things like that. Now, our main workflow in 3D modeling is you select a reference and you sketch, and then with that sketch, you'll bring it into 3D by revolving or extruding or doing other things with it as well. There's lots of different processes and ways that you can interact with sketches. Sketching is the fundamental skill that we need to learn right now. It's one of the most important skills in CAD modeling. Okay, so I'm going to select my reference. And then from here, so you'll notice this is the front reference. What I'm doing now is I'm holding down my middle mouse button to pan around and change my view. If I hold down Shift while I'm doing that, I'll rotate. Okay. You can also get to these options here down the bottom if you need to. There's other things you can do with your grid as well. Yeah, also up in here, we have the navigation pane as well. If you click on this home button, it'll always home your view to the original view here. And if you want to look at it from the top, front, side, angle, position, it'll highlight for you which angle you can look at. So they're both really handy tools to use. You'll also get a reference to which axis is where. So the red axis is always X, the green axis is always Y, and the blue axis is always the Z axis in our 3D environment. Okay. So I'll go through this and I'll go to Sketch up here, hit the Sketch button, and I'll start structuring out what I want to make. The first thing I'm going to do is I'm going to use this construction line type. So there's solid lines and construction lines. Construction lines you can think of as a scaffold, okay? So I won't be able to model directly from them, but they're there as a guide. So I'm going to go to construction line type, then to center rectangle. Some of you might see it down in your rectangle menu here. I've got mine added to my ribbon up the top. You can do the same by going to this little menu here and just going pin to toolbar. Also take the time to look at each of your tools. Some of them have a keyboard shortcut as well. So with my middle center rectangle selected, I'm going to work from the origin. You always need to try and build your 3D models around the origin if you can. Okay, so I'm going to go out. I'm going to start to move a little bit, and I want to make this, who remembers the constraint for size? 65 millimeters in every dimension. So I'm going to type in 65 and 65. Okay, so I've gone here, 65, and I'll press the tab key, and then 65. All right, and after that, I just press enter. You don't need to go and finish sketch just yet. We're going to sketch our spinning top in half profile. Okay, next tool I'm going to introduce you to is the line tool, shortcut L. And I'm going to sketch out the basic shape of my spinning top. I'm going to make my entire 3D form using just the sketch tool this time, okay? If you want to, you can try and use the spline tool, which is like a continually curving line. I'm happy for you to experiment a little bit with that, but there's certain sections you need to have correct, certain parts of your design that need to be correct at this point. First one, make this initial, we're going to do the stem of the spinning top. It needs to be 5 millimeters, okay? Any thinner than that, you can push it a little bit perhaps, but if you're making a stem that's only a couple of millimeters wide, it's going to break as soon as you try to test it, okay? So my recommendation is make it 5 millimeters in half profile, then when it's revolved, it'll be 10 millimeters wide. Make it shorter, but I would maintain the 5/10 millimeter dimension. Okay, so with my line tool selected, you'll see that I've made my first mistake already, and that is I haven't clicked off line type. You can think of this as like a caps lock button, okay? So it's like a switch that you can switch on and off. When it's on, it'll make dashed lines that you can use as a reference. When it's off, it'll make solid lines. So I'm going to go through and try and select that line that I've just drawn. There we go. And you'll notice that my line type button selects for construction. If I just check that off, it'll turn into a solid line. Okay, so I'm going to join to that solid line there, and I'm going to click once and bring a line down to about halfway on that red x-axis line. And I'm going to go out to the side. I'm going to use the grid available to me as a guide. I'm going to go out to here. I'm not being too particular with my measurements. I'm just making sure that everything I draw stays inside this box. Then I'm going to go out here. Now, the way I've made this arc is I've gone back to my origin point and I'm clicking and holding my left mouse button. Okay? And this will always draw a circular arc. So I'm going to make it go like this. So it's coming out this way, and ending up pointing in about this direction. Okay, after that, I'm going to draw a straight line just above and diagonal from this bottom point here. This is going to be where the tip of our spinning top sits. And I'm going to go just above. The tip is a very, very important part of your design and will directly relate to the amount of friction that you generate. And friction will work in the opposite direction to the inertia of your design. So that is the external force that will act on your spinning top as it's spinning. Okay, then after I've gone down while I was talking, I just did a little straight point here, and now I'm going straight back up to the top and joining that up. Now, one thing you'll notice straight away is that that area, this profile, has turned blue. That is the indicator to me that there's a fully enclosed shape, and if I wanted to, I could draw that out into a 3D object. If you've finished your spinning top and you don't see a blue shape, then you've got a problem. A lot of the common mistakes people make is they will hit escape or finish sketch, and then they'll go back in and put another sketch over the top of it. Okay? So let's just pretend that I've made a mistake. If I go back to the sketch button, it's going to create a new sketch. It's not going to edit my old sketch. If you have a sketch here that you need to edit, what you need to do is go down to the sketch here, or you can open up your sketches in your model tree, right-click, edit sketch, and it'll bring you back to that point that we just left, okay? That's really important. One of the common mistakes I see people make is they put in 5 sketches with different elements in each sketch and then wondering why it's not all sticking together. It only sticks together when it's all in the same sketch. Okay, so I've drawn my profile and I'm ready to revolve. Okay, so I'm going to select that until it highlights in blue, and then I'm going to go up to the revolve key here, the revolve button. Okay, so I've selected my reference, I'm picking the function that I want to run, and now anything in blue is data that you need to input or select. So in this case, it's telling me that it's got its profile selected, which is this profile here. It's saying that it wants to know what axis I want to revolve around. So if that's selected blue, all I need to do next is click on an axis. The axis can be the Z-axis or it can be the vertical line that I've drawn. Okay, so you'll see how it's highlighting in blue that vertical line going through. As soon as I click on that axis, it'll immediately make our 3D shape. Okay, and you'll still see that profile there. All right, I'm going to go OK on this, and that is as simple as that, the first iteration of my spinning top. I'm going to take you through some other essential things that you need to do. One of them is going to be adding positions for your weight to go in. We have 15mm by 5mm mild steel rod that you can place in your spinning top to distribute extra weight. And I'll show you some other datum as well, like the center of gravity, which I'll show you now. So if I go to inspect, there's a bunch of different data representations that I can depict here. The one I'm going to show you is this one called center of mass. And this is important because you'll be able to compare different designs' center of mass, take that data into testing and see which one performs better, or you can at least compare the qualities of that performance between spinning tops. So as soon as you click on center of mass, it'll ask you to select the body. And when you go OK, all it does is it makes this tiny little black and white dot here. Okay. And then what you can do is attempt to measure what you can do here. You can kind of eyeball it as well. So one of these dark squares is 5mm. So it's about 5, 10, 15, 20. My center of gravity is about 25mm above the base that I'm spinning on. Okay, so try and ask yourself what things you can do to manipulate that center of gravity. is a higher center of gravity or a lower center of gravity better for what we're doing here, okay? And I'll show you how to annotate this in and include this data in the next tutorial. Okay, so I'm going to leave that there as my datum. The next thing I'm going to show you is how to change your material. So at the moment, this is rendered as steel, and it takes on certain properties of steel in the modeling, okay? So what I want to do is actually change that to plastic, but it's not going to be, it's going to be solid plastic. Our spinning tops are, they're about 15 to 20% density, so there's support structure that's full of air, so yeah. So what I'm going to do for that is right-click and go to Physical Material. It'll take a little bit of time to think about that and bring up the menu, and we want to go down to Plastic, and what I usually select is just ABS plastic. Two things that you can do here. One is you can just drag your material straight on to your object, and that'll go into your design window there. The other thing is you can drag it into your design window first and then drag it across, but the most efficient way to do that is here. Okay, so I'm going to close that. There's other things you can look at to get data from your model. If we go to Properties, we can look at things like the density, the mass, and there is a calculation, a formula for density. It's mass over volume, and you get volume here, you get mass here. So you could actually calculate the density of your spinning top in the slicing program, because you get a weight for how much filament you're going to use in the slicing program. ABS and PLA plastic are quite similar. You also have things like moment of inertia. Okay, so the moment of inertia, you want to look at the extremities of this spinning top. I might make this just a little bit bigger if I can. So this is grams per millimeter squared. And you can see LZZ. So this is it's on the Z plane or down the Z axis, I think. We'll look into this one a little bit more later. And we can also go moment of inertia at origin and compare how they're different. At the moment, the numbers don't mean a lot because we haven't done our research into them, but I'm just showing you in this tutorial how you can do that. Okay, last thing I need to do for this, or two things I need to do, is put holes in the top of my spinning top and also put my initials or my name on it, okay? So now that we've made this form, I'm going to go and put some holes on the top of my spinning top. So now that you've drawn a 3D form, you can select any other flat surface as a reference for a new sketch. So I can sketch on here or here, and there's other things I can do to apply other 3D forms to these curved bodies or curved faces here. Okay, so what I'm going to do is click on the top here and add a sketch. And I'm going to add a hole towards the outside, and I'm going to make that 5.5 millimeters. Okay, you'll notice there's a bit of a collision here between this part of the sketch and this part of the sketch. That's okay. I'm just going to draw one, and I'm going to show you how to do a pattern repeat. We've got 6 weights that we can put into our spinning top, and I'll show you how to repeat this form that we make 6 times. It makes your workflow a bit more easy. So I'm going to go to extrude, and I'm going to click here, and I'm going to type in negative 15. Okay, so I just want my weights to sit flush there. But you'll notice if I look in here and go, okay, I haven't selected my sketch properly, okay? Because this sketch was segmented by this line here, I need to go back and make sure I've referenced it properly. So if I go back, right-click on my on the feature I've just done, which is an extrude, right-click, edit feature, and all I need to do now is just include this other part. You'll see it's selectable. So I'll hold down Control and then click and add that other part. and you'll see straight away, easy as, it'll add that other part into my model. You'll also see here I'm kind of cutting into the outside of my model. So what I might want to do here is actually move that back in. So I'll go back to my sketch and edit, and then I'll grab the center of this and move it down. So just about to there. And what you'll notice, being parametric software, it will regenerate. So I've moved that out of position so it's not interfering with the outside of my 3D model. I've done that very, very easily. You can go back at any time in your timeline and change most things. Next thing I'm going to do is called a pattern repeat. And I'm going to repeat this feature, this hole that goes in the top of my spinning top. So I'm going to go to that feature, and then I'm going to select this function here, called circular pattern. To find it in the base menu, go to create, and go down to pattern, and circular pattern here, okay? You might want to go to the menu and add that to your toolbar as well. So circular pattern, I've got an object selected, and again, it's going to ask me for an axis. So I'm going to click on the axis button, and I can select the cylinder here, or I can make my body invisible for a second by clicking on the eyeball, and I can click on this Z-axis here. Either way is fine. Okay, I can see where that's going through, but at the moment, if you look carefully, I only have 3 total repeats of that. If I change that number to 6, that'll put 6 holes in the top of my spinning top, distributed evenly around that central Z axis. Okay, once I go okay on that, all the holes in my spinning top are done. Now, the last thing I'm going to do is put in my initials on the top. So I'm going to go back to this part here and do a sketch. And this time when I make a sketch, I'm going to go down to create and put in text. All right. Now I can try and use this as a place to put on my initials, and I might be able to repeat that here and over here, but we'll just see how it goes. So I'm going to go on this line here. I'm going to type in my initials, A and G, but you'll see it sitting on the outside of this line. There's a few things you can do to change that. Under placement, I can make it go underneath. And under character spacing, I can play with this number to space apart my initials. You can also do things like add spaces to shift it around until you're happy with the positioning of it. Okay, so that's pretty good. I could even repeat that. That's pretty even around that point. I could repeat it here and here and here. You can also write your initials on the top here, whatever you want to do. Actually, no, don't write your initials on the top. I take that back. Don't ever write it up here because we need that flat part to do your printing. We actually print these from upside down. Okay, so my initials is there. You can find other ways to write your name, but I do want your initials on everything so I can identify who is printing. You can change your text size by changing the height here. So if I go down to 8 millimeters, it'll change the size a little bit, but then you might have to rejig some of your spacing. I'm going to stick back with 10 and go there. Okay, after I've done that and I'm happy with my text placement, I'm going to go here, go OK. And this is just a blue kind of reference, kind of like a sketch. To turn this into 3D, you have to extrude it. So I'm going to finish that sketch, and I'm going to hit with that selected. So if it's unselected, it'll look like that. Select it and go to extrude. And instead of doing an extrude, I'm going to make a hole, which is an intrude, and I'm going to write negative 0.5 millimeters. Just a little engraving in the top, right? You can also add a taper angle onto it as well. So I might go negative 40 degrees. And if you look closely, just put a little taper on your text. Okay. You can make that 0.2, 0.3 millimeters. I don't mind. Half a millimeter is fine. Okay, so there's my initials. What I'm going to do next is take that feature. I'm going to go back to my circular pattern, keeping in mind Yours will be down in this menu until you choose to pin it to your toolbar. So circular pattern, I've got my object selected. I'm going to hit my axis. I'm going to select this cylinder here as my axis, and I'm going to change it to 3. Okay, so that should be evenly spaced. Any uneven weighting in your spinning top will introduce a force called precession. Okay, and that will wobble, throw your spinning top out of alignment and waste energy. So precession is something that we need to manage. Smooth, even, stable spinning is what we want. Okay. After that's done, I'm ready to go. Okay. As you go forward, you might want to add color to it, but I'll show you that in the next tutorial. I'll show you rendering and I'll show you engineering drawings in the next tutorial. Okay. So from here, you need to save it using proper naming conventions. So that will be my last name, your first name, I don't mind, underscore, spinning top, and also version it, MK1. Okay. After you save that, if you look in your data panel, it will have this saved as MK1, and under here you'll see V1. Anytime I make a change to this, so say if I go down, select this, go to the press pull command and make my stem shorter, and then save it, this will change to V2. Or it should change to V2. Okay, so every time you make a change, so see here, V2 now, every time you make a save, it will version it for you, okay? So MK1 V2 tells me how many times you've saved it, okay? So to make a STL, you have to save it in the way I've shown you. Right-click at this very top here, that should have your name and your item name and your make, model number. You want to go down here, this is very important, save as mesh. After you go to save as mesh, you want to change your format to STL binary, change your unit type to millimeter, and change your refinement to high. So make yours like mine here, and then go OK. You'll pick this up here, and you can save it to your downloads folder. After you've saved it to your downloads folder, you can upload it to Google Classroom into the iteration 1 drop point, which I'll set up for you. Or you can download Flash Print, slice it, and go through that way as well. So I'll show you slicing quickly while I'm here. You should all have Flash Print downloaded. If you don't, you can just Google Flash Print online. So this is Flash Print. And the type of machine we're using is the Inventor 2 series. Okay, that's the one we have on the front desk here. So firstly, I'm going to go to File and Load File. I'm going to go to my downloads. I'm going to go here. And that will open my spinning top. It will go in upside down because it wants to start printing from that flat portion. And I'm going to let it do that. Once I go to start slicing, there's a few things I need to input. You're not going to be using basic mode if you're at this level. You're going to be using expert mode. So your print temperature is 210. I'm going to go down this menu here. Your base print speed will be 100. Travel speed 150. First layer minimum speed can be 30. Shells, I want 3 perimeter shells. And 3 top and bottom shells as well. For infill, I want you to select 15%, line, start angle 0, cross angle 90. This will make sure that your infill is centered in your 3D model. Okay, so that will eliminate precession of having unbalanced infill. Supports we'll add in a little bit, and that's all we should need. Okay, I'm going to save. I'm going to go save as new. Save it as spinning top PLA. So I can come back to that. What you want to do before you do anything here is go supports, linear supports, and 2 to 3 millimeters is fine. Overhang threshold, that's the angle from which it will start supporting. 55 is great. Auto supports, and that's the support structure that will generate underneath your spinning top. If I go back to start slicing, I'll go printer, custom material, spinning top PLA, and I'll go slice. That'll take a moment to slice. And then you can go to slice preview and you can get data like how much it weighs, 31.75. If you take that weight combined with the volume you get from your model, you can work out the density of your 3D model, which is data that you can use. I'm going to download that onto a USB preferably. After that's done, I can just plug it straight into my printer, click the USB and start printing straight away. The disadvantage of this is it'll only do one at a time if there's only one model there. So you might want to team up with some of the people at your desk and put in 2, maximum of 4 models here if you want to on this small printer. The max we can print on the large is 12. Okay? So if you want to do your own slicing, that's great. Otherwise, you can just submit your STL file. Okay? So to submit your STL file, save it as an STL, and you drop it into the location on Google Classroom. All right? Okay, that's gone on long enough, I think. So what I'm going to do is leave it there, and then I'll post this video up onto Google Classroom and YouTube. Okay? So thanks for watching, everyone, and we'll do the next tutorial soon. Cheers. I'll do my little outro screen. Yay, thanks for watching. All right, thank you guys.